Hello and welcome to the InterPlex. Paulo Murillo is a Colombian land change scientist with a doctorate in geography. He is a research professor at the University of Tolima and has worked with NASA and other international institutes on interdisciplinary projects that apply his expertise on satellite and aerial remote sensing. Murillo has a particular interest in evaluating landscape changes associated with the complex coevolution of natural and social systems through using dense forest sensing time series, and has focused much of his research to this point on mangrove forests and the Andes Amazon region. In our InterDialogue, we spoke about spatial patterns that are revealed through remote sensing, and also the complex socioeconomic drivers of deforestation and land use change, from armed conflict, mining, and illicit activities such as coca farming, to the expansion of roads, cow pasture, and the agricultural frontier. Murillo emphasized the importance of interconnecting these two forms of understanding, the so-called standard practice in remote sensing of pixelizing the social, with the complex, innovative, interdisciplinary practice of socializing the pixel, where a pattern is observed, but the social processes driving that pattern must be studied and understood. I began by asking Murillo about the broad applications and implications of his fascinating line of work. Nice to be here with you.
Yeah, good morning, Daniel. Thank you for inviting me.
Oh, of course. So let's start with a little bit of context on the kind of work you do. I'd like to ask you to explain what land use science is exactly, what kind of technologies and data sets are involved in this kind of work, and a bit further along in that, how does remote sensing aid in the understanding of land cover change and in guiding policy on ecolocation as well? You can answer some of these things for me to start.
Good. Well, land use science is looking for understanding what is the connection between humans and the changes that we can apply and we can modify landscape, but at the same time how natural drivers also are part of these changes that we can identify using satellite images or using geographic information systems. We can understand this land system science as a combination of social, economic forces that drive changes, but also how natural variability and how natural drivers might also affect landscape, and how landscape at the same time reflects all those changes that are at the same time driving by all these combining forces. And then currently, given the fact that we have a lot of satellite data and a lot of capabilities to modeling our land system, we are able to understand a little bit more how humans and the nature impacts changes on our planet.
Interesting. And to what kind of resolution are you able to get to? And maybe you can be a bit more specific about some of the data sets that exist for this satellite data. What do you use exactly when you're analyzing these data sets?
So that's a very interesting question because it depends. For instance, if we are trying to understand what is going to happen with our planet in the future, thinking a little bit more about climate change, the images that we are using, they have a coarse pixel size. It's a big pixel size because, it's difficult to predict the future. Then the pixel size that we use is a little bigger. We are talking about 5 to 20 kilometers, which is a very coarse resolution. But if we are looking for identify deforestation in Africa or land use changes in the Amazon, currently there are satellite data since 80s from a program called Landsat, and the pixel size is 13 meters. And That is interesting because it's a very long-term data set that is consistent, and the pixel size is 30 meters. And now the resolution from other satellites is much better. Now we can get free access to images around 10 meters, 5 meters. Then with that resolution, we can capture smaller changes linked to other specific land changes.
Okay. And are these satellites mostly through NASA or through other agencies or through the private sector? Where do most of these technologies originate?
Yeah, some of them comes from or are funded by the U.S. government, but there are another, for instance, Landsat. This program is funded by U.S., but there are other programs that are funded by the European Union. The Socialize has a much better resolution than Landsat, but the problem is that they started probably like 10 years ago. The time series is smaller than the Landsat program. But yeah, India also have a Socialize program. China also, and Russia also has their own like Socialize to monitor changes. And South America, Brazil, and Argentina, they also have some Socialize.
Okay. So you're able to use all this different data and then detect patterns within the context of land use science.
Yeah, but probably the easiest ones to get access and to work with them are the programs that comes from United States and the European Union, because maybe they have a much better platforms, better training, and more resources to explain people how to use them.
All right. So a little bit of personal context. We met originally at a conference specifically about mangroves, organized by a mutual colleague of ours, Ernesto Mancera, who's a marine biologist. And there were hundreds of researchers there, most of them marine biologists or people focused on coastal ecosystems. But your group was a bit different. You know, there were physicists, there were engineers, people involved in ecology, yourself, with remote sensing focus. I guess I want to ask you, how does the kind of work you do foster interdisciplinary collaborations? How does the technology and the focus on detecting patterns bring in experts from different kinds of disciplines?
Well, that's a very interesting question, because right now I am working with mangroves to try to understand or monitoring what is happening with mangroves, but using like satellite data. However, the people that work at field, the biologists, they, in some cases, they are focused on something very, very specific, and probably they don't have this more regional view about how can we use satellite data to identify these kind of specific traits that in some cases they are looking for. For instance, they are very good to identify invasive plants that in some cases grow up surrounding mangroves, and these invasive species, they affect mangroves and they affect the landscape, and maybe they know pretty well the species, probably the specific locations, and another like physiology aspects about these invasive plants. But from satellite data, we can map the extent and the distribution of all these species in a larger area. And right now, for instance, we are working together in the Ciénaga Grande in Santa Marta, and we are trying to differentiate, try to discriminate where are mangroves located and where are all these invasive plants that, generally speaking, they grow up surrounding mangroves but compete against mangrove for resources and can affect mangroves. Then that's an interesting combination, because from an ecologist or biologist point of view, they knew pretty well all these species, the mechanism behind them, but they combine this info with remote sensing to try to have a much better understanding about distribution and location.
Very interesting. So it helps to sort of bridge the field work and the remote sensing data that comes from up above. So a large link that's at play. I know there are also social aspects that are involved in this kind of work you're doing. And you've spoken to me about it and you've started to write about it. The two aspects that you call pixelizing the social and socializing the pixel. Can you explain what those are and what is the normal way of doing things in your line of work? And then what are the possibilities for then socializing the pixel?
Yeah, that's a very interesting theory that started like many years ago, and probably now is taking a little bit more attention because in some cases we don't have the full resources to go to the field and collect all the social data, all the specificities, the specific aspect that probably we can relate with our satellite data. Then from all these people that work using remote sensing, we basically use something called pixelizing the social because, for instance, we know that in the landscape we can see a river or we can see an agriculture plot or we can see forests in a satellite data. And because we can see those land cover types, we can easily take training data. We could say, oh, this is a forest, this is water, this is agriculture plots, and we can classify the images. That is the conventional remote sensing point of view that most people do. And given that we can see the training data, then it's probably easier to create these maps. However, once we want to have a little more detail about what is the mechanism, what is the driver that is creating this new agriculture plot in this particular location, it's more complicated to get access to that kind of information. Drawing like points or polygons in a satellite image. And the socializing the pixel is basically a different way to understand landscape. Once we use socializing the pixel, is we see the satellite data, we see a pattern of change, or we see a specific distribution of information there, and we try to classify that pattern into a specific process that produce that specific pattern. And then in that way, we don't need to go to the field. I mean, we can, but the idea is that landscape itself tell us something about the process that is behind. Then, if we don't have the ability to go to the field, we can use this socializing the pixel approach to trying to link the change that we can see in the satellite data with the process that drive those changes. Then that is kind of like a difference between both of them, and it's something that probably is going to be more useful in the future to try to understand things associated, for instance, with our conflict, with illicit land activity, with illegal, for instance, logging or illegal agriculture, aspects that are very difficult to go to the field and collect, but probably using socializing the pixel might help us to have a good an approach that probably can help us to understand a little bit more what is happening.
It's really very interesting and beginning to understand a bit more the different levels that can work at. Can they work in parallel, these two processes, pixelizing the social and socializing the pixel? Can there be sort of interdependent research initiatives that are informing each other, I suppose? So the pixelizing the social, the more standard approach to things, and the socializing the pixel, where you're being informed by the social drivers to know in more real time what are the patterns that you're detecting. Is there potential for that kind of a interlinked collaboration between those two processes?
Yeah, that is something very interesting because we can use both of them at the same time once we don't have a good or or probably enough training data to classify the images. If we don't have enough training data to understand if this is an illegal activity or this is a no illegal activity, then we can create some hypotheses based on those changes, and then we might need both of them to try to understand much better what is happening. However, if we have a decent amount of training data about the social processes that are behind these changes, probably we don't need the socializing the pixel. We just go to the conventional pixelizing the social, and we just classify the image, and we know that these changes that we are mapping, we can understand the process that is there because we have a decent amount of training data to do that. Then we use socializing the pixel in the cases in which we don't have decent or enough training information to understand the process behind the changes. Then that is the connection between of them, because if we are looking for something very specific, it's probably that we don't have enough data. Then we need both of them to inform.
And what are some of the ways that you do collect this social driver information? Are there surveys with communities? Are there other kinds of field, knowledge sharing circumstances that you're able to understand on the ground what some of these, drivers are? Are there other proposed ways to do that? And then the other question is also coming from the more conventional side of pixelizing the social. Is there a way to then share that information more effectively with the communities that are then helping to inform the process of socializing the pixel, if that makes sense? So I wonder if there's a way of information flow and a bidirectional information flow that's proposed in these processes as well.
Yeah, for instance, for pixelizing the social, there are currently more free available data to do that. Given that now we have all this free satellite data available, there are many different land use, land cover products that are already created by big groups globally. And we can use those sources as a first phase to try to collect training data, because the maps are already created. Then we can use these maps to actually extract our training data and create probably much better maps using the training data collected from them. That is something very important, because I think every single day the maps are not going to be just deforestation and not deforestation. They are going to be more specific. Then we can collect more data more faster and with more a little bit more detail. That is from the side of pixelizing the social. And from socializing the pixel, the theory here is like we can see a specific change on the satellite data, but probably we can go there, right? Or probably that pattern occurred in Colombia and that pattern is the same in Brazil. Then we can ask to people that feel in Brazil about that pattern. For instance, if we see a very regular pattern, and probably in Brazil they tell us that is something for expansion of agriculture or new settlements. And if that pattern is the same in Brazil and we see that pattern now in Colombia, then we can say, okay, now this pattern that I can see here, without going there, without actually talk to people there, we can suspect, or we can create a hypothesis that probably that pattern is associated with agriculture and new settlements. However, at the same time, we need some kind of verification or validation of those changes. Then the pixelizing the social might appear there to try to classify that image and say, oh, yeah, probably this is agriculture, this is a new settlement. And at the same time, if we have the opportunity to go there, then we can discuss with the people about what else is happening there. But that is a cool example about the connection between both of them.
Interesting. Let's talk about a couple of specific regions there and areas that you've researched in and how this framework of socializing the pixel can apply to that. One particular region that's of interest to me and an area of research in is the Andes Amazon region. I'd love to get some of your opinion on why this region is so important and then how this framework can be applied to it, because it's an area of such high level of deforestation and many complex drivers of deforestation in Colombia especially. And then, we can talk about it after, but also the Chocó region and the Gulf of Tribuga. I know that you had done some work also with the communities there in addition to the remote sensing data. So maybe you can use those two regions as examples of this framework and also just expand upon the importance of these regions too.
Cool. Yeah. In the Andes Amazon region in Colombia is particularly very important because it's that connection from the north of South America, basically from the Andes in the north of South America. And there is a connectivity process from the Andes to the Amazon, and that connectivity goes until the south of Brazil. There is a very large scale endemism in that area, and there is a lot of mobility of species, of fauna, flora that moves through this location. One of the issues in this particular location is that since 1950s, there is a lot of people that they were looking for lands, and these lands are pretty flat after you move from the Andes. And many people started to live there, campesinos mostly, and they started to expand these lands, and they started to clear a lot of forests that connect the Andes with the rest of the Amazon. And currently, there is a lot of cattle ranching farms in this location that are affecting the moving of species. Then it's important to keep this area connected, because in the future, some vital ecosystem services such as water or the availability to agriculture are going to be affected if we don't take action to protect or to maintain some specific areas with pristine forests. And in this location, is the process of colonization has been very slow, but at the same time has been very noisy. There is no regular or very specific pattern of change in this region. Most of the changes are not random. They are, we could say they are kind of noisy. In some cases, we see changes in one location, probably linked to pasture expansion, but probably some years later, there are no more pastures. There is a forest regrowth. In the same location, we can see tiny plots for coca farming to produce cocaine. Then the two more common changes that we can see in this region are linked to pastures for establishing cattle ranching lands, and some tiny plots for coca farming. And understanding where are the location of this coca and this pasture is important at the same time to understand what is the impact of these activities on landscape. Mapping coca is very difficult, super difficult. It's more difficult than mapping pastures because they are probably in a bigger lands, but coca is a little more difficult because they are tiny plots. Then that's something that in which satellite data can be very useful to try to identify these land uses. In the case of Tribuga, well, this is a completely different location that has been very preserved for many years. There are no roads there. Population is few. Then forests in Chocó has been particularly stable across time. However, there are some future threats that can affect Tribuga or some parts of Chocó probably in the future. But in these locations, the role of communities has been very important. They know pretty well all the benefits that they receive from nature, from forests, from mangroves, from the ocean. Then they have been able to probably protect in a much better way their ecosystems than the campesinos that probably are in the Andes Amazon region. Then that is something, socially speaking, very different in terms of Colombia.
And your work in Tribuga was focused on the mangrove forest, the coastal ecosystems, more than anything?
Yeah, in Tribuga, we were trying to understand a little bit more in detail what is the status of mangroves there, or if mangroves has been affected or if they remain pretty stable. We found that in general mangroves are stable there. However, people continue using them to extract wood for cooking, for instance, for fire. They go to mangroves frequently to extract some specific fisheries. However, the impacts that we link from satellite data with the interviews that we did and the social discussion that we have with the locals there tell us that probably their impacts are still minimal. They are not giant changes, and that is important because I think this region can continue in the same way for many years more, even though all the political interest to establishing a new deep water port in this location and the future construction of roads that can affect at the same probably rate. And we can see in the future probably the same changes that we see in the Amazon now can be in the future, can affect the future of Tribuga. Because once a road is constructed, we can see a lot of changes in the surroundings.
Yeah, I was just going to ask you about that too, just to emphasize a couple of other drivers that maybe weren't mentioned that have strong social aspects, roads, and also mining, which wasn't mentioned. Is there anything that you can talk about in terms of the Amazon region, Andes Amazon region, and the Chocó in terms of the expanding gold mining, and if these are things that can be detected through remote sensing, and also if patterns of deforestation show up in the kind of work you do once a road is constructed? Are there clear patterns of sort of the expansion of deforestation that then come around the roads?
Yeah. Roads is one of those human drivers that is that has been very, very well studied, and we knew pretty well from the land system science that once you have a new road in an area with a lot of forests or pristine, we can see in the future a lot of changes surrounding there because the value of those lands increase. There is not the same of having a large farm without getting access to transport, agricultural products, or probably tourism. Once you don't have a road, and once you have it, many people are going to take advantage of that. That is common in all those Amazon countries. Also in Africa, it's very common. And then that is something that can be very easily detected and very easily monitored using free satellite data. And in the case of gold mining, well, the pattern of change for gold mining is probably smaller and less probably visible once we use satellite data. However, we can, and there are studies that actually are able to map what happening surrounding rivers when there are some machines that is started to extract soils and moving combine the water from the river with the soils to try to extract gold. In Chocó, close to Atrato River, there are locations in which it's very easy to see the destruction of the flows of the rivers. to extract gold mining. And satellite data has been very effective to do that. We can currently detect pretty well the changes in soil and water surrounding the rivers, and as a preliminary way to identify the extent of the affectation of that. And even though probably the deforestation is not as larger as we can see areas deforested for pastures in the Amazon, there is a lot of chemicals that they use, and the water could be potentially polluted for this activity. Then that is something important to try to monitor and try to understand if this extent of changes can be also linked to water quality.
Interesting. So monitoring on the ground combined with the satellite monitoring. Yeah, so you're talking about being able to monitor hydrological processes through the satellite data. I also wonder how topography impacts your ability to see these kinds of changes. Like what level of detail are you able to get down to in terms of hydrological processes with the kind of technologies that you use in your work?
Wow, that's a very interesting question because, for instance, Chocó is one of those rainiest places in the world, and if we want to use optical satellite data, which is the light that we can see now with our eyes, and these locations are currently with clouds, then all satellite data most of the time looks with white colors. Then we can even see what is happening on the surface. Then that is one of the problems, which is completely different in the Amazon. The Amazon, the availability of satellite data is more. Most of them are free or free cloud images. Then we can map easily changes. To try to avoid these problems, there are another satellites that are called radar data or radar images, and these images can pass through clouds, and then they can give us information about the surface and about the water. Topography obviously affect because of if they're in higher locations, well, the availability of having images is low, and we have to apply a lot of corrections to the data to try to have something more consistent. And for hydrological processes, for instance, in the case of the quality of water, the research is quite new because this is probably people are using other satellites that have different spectral regions that can tell us information about the quality of the water. But that is something that I started probably less than the 10 years ago, probably, because it's still difficult to try to, from satellites, try to say, oh, this water is the clean water, and this water has been affected by some chemicals, or probably this water is affected by a lot of sediments that probably are okay, it's just sediments. But that is something that is a new line of research for the land system science.
Yeah, I see a lot of potential there for combining efforts, the new line of research that you're working on, and also more cumulative impacts to sediment transport, and also community water quality monitoring. All these things can probably be combined to complement each other into more, integrated approaches to understanding the changes.
Yeah, for instance, there are a couple of very interesting ideas for water, and one of them is the role of salinity, how if we can actually identify levels of salinity, this is for the case of mangroves. And another very important one is if we have a mangroves area and we can see new invasive species, for instance, all those species are there now because there are a lot of chemicals from other locations for agricultural systems that are moving through the rivers. And once they arrive to the mangroves, they stay there. And although that a lot of chemistry like nitrogen and health to these invasive species to show up. Then it means that probably the invasive species is a result of a lot of chemicals that people use in other locations, right? Linked to agriculture system, and now we can see the problems very close to the ocean or very surrounding the mangroves. That's something very interesting because we can use the invasive species to understand the availability of nitrogen or other chemicals that people use for agriculture. There's something interesting that probably we should work on it.
Yeah, it's really fascinating. A lot of possibilities there. Something I want to make sure to ask you about is the differences that you detected in the satellite data, specifically to Colombia, between pre and post-conflict times, the 2016 signing of the peace accords. What were the patterns like beforehand, and what was showing up afterwards, and what regions were most impacted? And also what are potentially some of the top drivers of change, land use change after the signing of the peace accords?
Yeah, that is something also very interesting because Colombia is a very nice lab to study this relationship between our conflict processes and land use changes. Before 2016, or probably even until 2012, especially in the Andes Amazon region, the deforestation and land uses changes, the rate of changes were very low. Once we see an historical perspective of changes, we can see that deforestation has been always showing a very accumulative process. Even slowly, there are more changes. One of the reasons of that is that FARC were very effective to prevent changes to communities. They create rules, and then people follow those rules. Then deforestation was, generally speaking, very slow. However, once they left the territory, not even after the peace agreement, a little probably before, once they knew that this thing was coming, the changes were more faster. And this thing happened across.
Just to give some context, you're talking about the Marxist guerrillas, right? The FARC. They're the ones that had control over that.
Yeah, I am talking about the guerrilla group, the FARC, that they signed this peace agreement with the Colombian government. And then after they signed this, different actors, the same campesinos, other locals, other elites, groups from another parts of Colombia, they collectively work together to expand lands and the magnitude of change was very high. Then we can see that 2017, 2018 was the highest amount of deforestation across Colombia, and that change was completely different to the previous 20 years or even 50 years before. Then those are the changes, and that thing happened. That was something that we can actually document it using satellite data. There are a lot of papers, there is a lot of research, many people working on that. And probably one of the most important drivers behind of this was speculation about the land, the price of the land in the future. Then people clear land, and some of them establishing pastures, and some of them just was having the land there because they think that in the future that land has the value of that land will be higher. Then that was probably the driver of that was driving all those particular changes. And the most common driver is still cattle ranching. Cattle ranching. Coca is remarkably small, even though coca during the last year has increasing a lot in Colombia. Is basically it's like a 50 times less than the deforestation linked to cattle ranching.
Okay. And I think you had mentioned to me before that before the signing of the peace agreements, the deforestation that you could detect by satellite data was very random. and afterwards it was a much more predictable pattern that followed patterns in other parts of the world, like Brazil as well, in the Brazilian Amazon. Is is this part of the work that you do? You look for patterns that are more predictable, so that there can be more, let's say, policy recommendations, things like that, so that you actually can predict what's coming up afterwards, after a certain social driver or other kind of driver that comes about.
Yeah, that's very interesting because Colombia has been in a internal armed conflict for 50 years. Then, when I mentioned the patterns were noisy, is because all these rebel groups, the guerrillas, paramilitaries, government, policies, campesinos, which are small peasants, small farmers, indigenous communities, the patterns were kind of noisy. Then it's difficult to see all those patterns in other locations in the world. However, once this peace agreement started, and this group, the FARC group, they left the territory, there is a new mentality about what is going to happen, how we are going to use these lands in the Amazon. Still, the Amazon is giant. The availability of land there is vast, is enormous. Then I think that once this group left the territory, there are new ideas about how we can use this land. Then now, rather than seeing a noisy pattern, no regular changes, regrow of forests, now we can see very regular, very well delineated new patches of deforestation that never occurred before. Because before, the changes were more probably linked to small farmers that probably clean a couple of hectares or something like that, and the change was very regular in that plot. But now we can see plots from like 1 kilometer by 2 kilometers, perfectly measured, and then we see a new pattern. That's something different. That tells us about a new mentality, how people are using, how people wanted to using these lands now, and that pattern is actually more linked to some patterns that we can see in Brazil. Then it's probably a more industrialized pattern that probably before doesn't exist. And then that is something that probably is happening in Colombia. During the last year, deforestation decreased a lot. Now it's kind of stable. But some people indicate that during the last 3 months, deforestation increased a little bit more, probably because of fires or because of the dry season. But I think we might have much better information about that by June this year, try to understand if deforestation again increase a little bit more.
That's very interesting and important for projecting what may happen with the forests in the Amazon and Andes Amazon region in Colombia going forward. All right. I want to make sure to ask you before you go about some larger projects that you're involved in, and also some more advanced technologies that you mentioned to me. You said that AI might be used for pixelizing the social to enhance that process. Also, this project Pangea that you mentioned to me, which is looking for more global patterns and trends related to land use changes. That's run by NASA, I believe, and you're involved in that. And I'd like to know if socializing the pixel has the potential to fit into that project, taking in the concept of maybe socio-ecological systems. So maybe we can close off by you answering some of those questions, because I think they're quite fascinating and have a broad reach towards the kind of work that you're doing.
Well, there is the Pangea project. What was the first part that you asking me?
I was asking about how AI might help to enhance
yeah.
and any other future advanced technologies that you're aware of that could be thought of, but that in particular. And then, the Pangea project through NASA that you're involved in, and how socializing the pixel can be involved in that, in looking for global trends and global patterns with land use change.
Yeah, the AI is something that is going to be part of the pixelizing the social, because what makes AI very effective is the fact that if you have a giant amount of training data, if you can train these AI modules using a lot of information, then your outcomes from or the satellite images that you are going to classify are gonna be remarkable good, because all these AI modules that we can apply to satellite data are very effective to remove outliers, to remove things that you are not interested, or even problems on the same images. You can clean up all that information and you can just get the specific classification that you wanted in that image. And at the same time, you can even, more than even classify the image, you can even, in some cases, I think in the future, even classify the process itself. That makes AI, in the future of AI, at least for satellite data, is gonna bring a lot of new ideas about how we can understand our land systems. And for instance, in the case of making deforestation maps, which is something that probably currently we are very good doing, using AI, being applied AI to satellite the images and just saying to them, hey, classify this map into forest and no forest, or forest, deforested forest, is going to be amazing, because it's going to even real near time detect all these maps. Currently, there are some maps that people can create probably every month, every 2 months. But now I think with the capabilities of all these AI modules, we can even classify things faster and get in more detail about things that are difficult to be detected using AI and satellite images. And I think that is linked to the Pangea Project. The Pangea Project is a proposal that is coming and that is going to be funded by NASA. And it's a project for about 7 to 9 years. We are working right now. It's a lot of people in Africa, South America, to try to identify this specific extent or what we understand for what are the land systems that we are going to monitor for Africa and South America. And the proposal is due by December this year. They might expect to be funded by next year. I think the project officially will start in 2025, at least for 9 years. That is the hope for this project. And the project is trying to use all the satellite data that we can get, even coarse detail or very specific detail, to try to monitor and understand the diversity of the Andes Amazon watersheds and the Africa's ecosystems. Because even though people think that everything is like the forest is homogeneous, the forest is not homogeneous. And then they wanted to try to create maps that not always said, oh, this is forest. Okay, no, this is not forest. There are some different species here and there are no other species here. And they wanted to understand a little bit more what are the connections with this and climate change. As I mentioned, it's a project for about 9 years. They are still working on the specific objectives for this white paper proposal. Well, we hope the people that are collaborating there to try to, that our voices are part of this project, and probably that if we need to collect social data, if we need to go to field, if we need to collect some data for species, for animals, or if we need to interview indigenous communities or peasants communities, then that connection between locals and satellite images will be probably stronger. It's like a bottom, it's top down, but at the same time is bottom down.
Bottom up. Bottom up.
Yeah,
bottom up and top down, right? So those working together.
Down, working together, and at the same time, if we might not be able to collect all the data that we have, to try to use this socializing approach to try to understand a little bit more what happened, and using satellite data to try to validate all these hypotheses. Then that is, generally speaking, the idea for the Pangea project.
And since you're considering multiple large-scale regions there, if that works, you'll be able to detect more, let's say, global patterns of change, things like that can then be applied and replicated in other regions. Is that the hope of a project like Pangea?
Yes, to try to understand the changes that might be impact for natural factors, but also what is the role of the institutions that are there, the groups that live there, right? How this information can be used to preserve a little bit more the ecosystems, right? Because the idea is at the same time to try to maintain these ecosystems in a status that remains probably stable. That is the idea also for this project.
Okay, excellent. Well, thank you, Paulo. It's fascinating both on the local scale and the global scale that you're working on. And I look forward to talking to you more about these topics.
No, thank you, Daniel, for inviting me. This is very nice to express these ideas in a more informal way that probably people can have a different understanding or more specific understanding about how we can monitor our planet, how can we detect things that probably are undetectable, but that we can, using some social aspects, we can having a much better understanding about future policies that can preserve humans and landscape together, because we need them to stay in this planet.
Absolutely. Yeah, well, continue the great work, and let's keep seeing the ways that we can communicate this to a larger audience. It's very important.
Awesome. No, thank you, David, for inviting me.
Okay, talk to you soon, Paulo. Bye-bye. Thank you for joining us for this InterDialogue. You can subscribe to be notified of future episodes and by following us on our social media channels at the InterPlex. Visit our website, interplex.org, for more interdisciplinary and intercultural content, and to join our growing collaborative community.